In this lesson today, we're going to take a look at other angle relationships in circles using different lines and segments that we've talked about to this point. So you know that the measure of an inscribed angle is half the measure of an intercepted arc. This is true even if one side of the angle is tangent to the circle. So Theorem 1011 says that if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So here you see we have our segment AB, and then we have our tangent line, which we see out here. So what we're saying is that the measure of angle 1 in this case is going to be half the measure of its intercepted arc, which, if you notice, the points would be A and B here. So the measure of angle 1 is going to be half the measure of arc AB. If I were to find the measure of angle 2, well, there you can see the intercepted arc. We have going from B to A in the other direction. So the measure of angle 2 is going to be half the measure. And since this is a major arc, we're going to have to use 3 letters to name that. So the measure of arc BCA. So same thing applying that we looked at in our last lesson, except now we don't have two segments in our circle. We have a segment and a tangent line. All right, first example here. So we want to find the measure of angle 1. We see that 1, we have M, which is our tangent line. We have a chord AB here. So measure of angle 1 is going to be half the measure of its intercepted arc, which in this case is 132 degrees. So the measure of angle 1 would be half that, which is going to be 66 degrees. All right, so in example B here, we want to find the measure of arc DE. So we see that that's the minor arc out here. So there's 2 different ways we can approach this. We could first of all find the measure of arc EFD and then subtract that from 360. Or we could find the other angle on the other side over here and then use that with its intercepted arc to find the measure of arc DE. I'm going to go ahead and use that second method since it's going to be a little bit easier in my opinion. So we know that in this case, the measure of this angle here is 110 degrees. We can see that this is going to form a linear pair with that, so we know it's going to be supplementary, which means that the measure of this angle here would have to be 70 degrees so that they would total 180. We then look at that, and we know that that is going to be half the measure of the arc that's on the outside. So we're going to need to double that measure in order to find the measure of arc DE. And we would come up with an arc measure of 140 degrees. So again, the other way you could have approached it is you could have looked at the measure of this arc out here, which would have been 220 degrees, subtracted that from 360, and then come up with that 140 as well. All right, so when we have 2 different chords, sometimes we're forming angles that are inside a circle. So if 2 chords intersect inside a circle, the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So that description is really confusing. So let's take a look and let's start actually naming some of these things so it makes a little bit more sense in this problem. So if I'm looking for the measure of angle 1, what we're saying is that the measure of this angle is going to be half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So the arc that's intercepted by this angle here would be arc DC. We see the vertical angle to that, which is over here, and the arc that's intercepted there would be AB. So the measure of angle 1 is going to be half the measure of arc DC plus the measure of arc AB. So again, the measure of this angle, we're looking at its intercepted arc, and then the intercepted arc that's vertical to that. So that's intercepted by the vertical angle of that. And then we're going to find the sum of those and divide by 2, half of that sum. If I take a look at angle 2 here, so the measure of angle 2 is going to be half the measure of its intercepted arc, which is BC in this case. And then we look at the vertical angle to that, and then the arc that's intercepted there would be arc AD. So that gets a little bit confusing. When we start working through some problems, it'll probably start to set in a little bit more. Before we practice those, let's go ahead and take a look at some other relationships. So here we have angles that are outside the circle. So here we're dealing with tangent and secant lines. If a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So if you look at this first one, notice that we have a tangent and a secant. So what we're saying is that the measure of this angle here, you'll see that there are two intercepted arcs. So the first intercepted arc right here, AC, and then we see as we continue, we have a second intercepted arc over here, which is BC. So the two lines kind of form two different arcs in that circle. So what we're saying is that the measure of angle 1 is going to be half the difference of those arcs. So we would take the larger arc, which would be arc BC, and subtract the measure of the smaller arc, which would be AC. Again, this is with a secant and a tangent. All right, so if we look at the next one we're going to be looking at two tangents. So we have two tangent lines. Again, going to be the same thing when we look at the intercepted arcs here. You're going to notice with this, it actually ends up forming the entire circle. Because they're tangents, those are our 2 points of intersection, and then our entire circle is split into two parts there. So this is going to be equal to half the difference of the larger arc, which in this case is major arc, PQR, and the minor arc, which would be arc PR. Lastly, down here, we have two secant lines. So with this, you can see the intercepted arcs that we have here. So we have WZ, and then we have XY over here. So again, that measure of angle 3 is going to be half the difference of those arcs. So in this case, it would be the measure of arc XY minus the measure of arc WZ. So if you take a look at those, all using the same computation, so coming up with the answer the same way, it's just we have different scenarios because of the secant versus tangent lines. So look for those two intersections, and again, this is when we are dealing with an angle that is outside of our circle. The previous one we were looking at an interior angle, which we had the sum, and we were taking half of that. Now we have an angle outside the circle, so we're looking at the difference and then half of that. All right, so let's look at some examples. So here we see we have two chords, FH and GJ, which intersect inside the circle. So here we have an angle that's inside the circle. So remember, this is going to be half the sum of those arcs. So if we're looking at X right here, we know that the measure of that angle, or just X in this case, is going to be half the measure of its intercepted arc, GH here, which is 140 degrees. And the sum of that, and if we look at the vertical angle, and then the arc that's intercepted there, FJ, which is 112, we're going to go ahead and find that sum, and then take half of that sum. So if you add that, you're going to get 252, and then taking half of that would give you an angle measure of 126 degrees. Next example, we have a tangent and a secant line. So here, notice that the intersection of our lines, or where our angle is outside the circle. So remember that with this, we're looking at the difference of those arcs. So we know that X is going to be half the difference of the two intercepted arcs that we have here. So the intercepted arcs, we see we have 72, and then we have 170 over here. So we're going to find the difference of those. And when we do that, we end up with an angle measure of 49 degrees. The next one, we want to find the measure of arc TQ if the measure of arc SR is 63 degrees and the measure of angle TVQ is 76 degrees. So let's go ahead, let's label those things in here since they're not already labeled. So we have TVQ, which is 76 degrees. We have the arc SR, which is 63 degrees out here. So remember with this, you cannot just say that this arc is going to be equal to that or even double that, because this point right here is not the center and is not a point on the circle. So we're not talking about central angles or inscribed angles. We have some other angle that's inside of our circle. So with this, we need to use the fact that the measure of that angle is going to be equal to half the sum of the arc and the intercepted arc opposite that. So if I start writing this out, I know that the measure of angle TVQ is equal to half the measure of arc TQ plus the measure of arc SR. So I know that we do know some of these values, but I just wanted to write that out so we could see what we're looking at here and try to figure out how we're going to then solve this. So we know that the measure of angle TVQ is 76. So let's go ahead and fill that in. We don't know the measure of arc TQ. That's what we're going to be trying to find. And we know that the measure of arc SR is 63. So let's go ahead and fill that in. So at this point, really, we're just solving an equation. And I know this is not a variable, but we're basically going to treat that like it were. And if you'd rather replace that with a variable to solve it, you're certainly welcome to do that. So there's a couple different ways that we could go about solving this in terms of an equation. I think the easiest probably at this point, if we just multiply everything by 2, it's going to go ahead and eliminate that fraction of 1/2 out here in front. So 76 times 2 would give us 152. Again, that half is going to cancel out with the 2 there. So then we'd have the measure of arc TQ plus 63. And then at that point, we're just going to need to subtract 63 from both sides. And we find out that the measure of arc TQ is going to be 89 degrees. All right, the next one. This one did not print out very nicely on my screen, but looks like it should be okay on your papers. So with this, notice that we have two secant lines, and we can see that the intersection is outside of our circle. So we have to remember that we're looking at the difference of the arcs when we start trying to solve this. So we see we have our two intercepted arcs right here and right here. So if you remember, the measure of that angle is going to be half the difference of those arc measures. So let's go ahead, let's start writing that out. So we know that 30 would be half the difference of my larger arc, which is 5x plus 10. And the other arc, which is 3x plus 4. Really just got to be careful here with those expressions as you are starting to solve this. Remember, with your combining like terms, when you're looking at this minus right here, remember that's going to really get distributed to both of those terms with a 3x plus 4. So when we start solving, we have to make sure we keep that in mind. And keep the very same over here. I'm just going to go ahead and keep working inside and let's simplify this out. So we'd have 5x minus 3x, which would be 2x. And then we'd have 10 minus 4, again, because that minus is getting distributed through, which would be a positive 6. At this point, I'm going to go ahead and I'll distribute here. You could multiply both sides by 2 to eliminate that fraction, or distribute. I'm going to go ahead and distribute. So we would come up with 30 equals x plus 3. And then just subtracting 3 would give us an x value of 27. As with all of these types of problems with the expressions, certainly we could plug that back in. We were just asked to find x, But we could substitute that back in and then find the difference of those arcs and divide it by 2 to make sure that it is in fact equal to 30 degrees. All right, let's take a look at last couple examples. Folks, feel free to go ahead and try to work through these on your own, pause the video, and then come back to chat. So number 1, we see that we have a chord and a tangent line. So since our vertex is on the circle, we know that it's going to be half the measure of the intercepted arc. So we know that the measure of arc ACB would be double the measure of that angle, or in other words, would be equal to 240 degrees. The next one, we have an angle that is on the interior of our circle. We can see that 52 is actually referring to this angle that's over here. That's a little bit confusing because it looks like it's in this place, but we can see the arrow marking that it's over here. So since this angle and this angle are the two that were given, and this is what we're trying to find, really what we want to do is either find this angle here or the vertical angle so that we can then use the fact that we have that angle on the interior and can then find half the sum of those two arcs. So if this angle is 52, we know that the other one must be supplementary to that. So we know the other one must be 128. And since it's our vertical angles, we know they could be congruent, so we wouldn't really need to find both of them. Either one would be perfectly fine. So we know that 128 is going to be equal to half the sum of those intercepted arcs, so of 144 and x. At this point, solve it however you'd like. I'll go ahead and multiply by 2. So 256 is equal to 144 plus x. And then when you subtract 144, you should come up with an x value of 112. And then the last one there, you can see that we have an arc, or sorry, we have an angle that is on the exterior of our circle. So we know it's going to be equal to half the difference of those intercepted arcs. So when we're looking at our intercepted arcs, we're focused on this and this. So we know that 26 is going to be equal to half the difference of y and 30. I'll go ahead, I'll multiply by 2 here as well. So 52 is equal to y minus 30. You'd add 30 to both sides, and you come up with a y value of 82. All right, that's it for our notes today, folks. Go ahead and take a look at that quizzes, and then if you finish that early, go ahead and get started with your homework. Let me know if you have any questions. Have a great day, folks.